All right, hi everyone. So we are going to look at another topic in terms of graphing parabolas. That's really easy, so I figured you guys would be okay with learning it as a flipped lesson. So what we're learning today is something called stretching and shrinking of a quadratic formula, which are just big words for making something skinny or making something wider. So let's start and talk about a parent function. So we have the simplest parabola, or the parent function of a parabola is y equals x squared. It's called your parent function because all other parabolas can be created by transforming this graph. So think about a parent function. Think about your parents. You and your siblings are kind of like replicas of your parents. So we start with our parent function, y equals x squared, and then every other parabola is based on this parent function. So you don't need to really memorize that. Just know that y equals x squared is like the basic parabola. So based on this graph, we want to know the vertex. Again, the vertex is your turning point. So it's 0, 0 in this case. Your axis of symmetry is the line that cuts the parabola right in half. So arcs go through 0. So the axis of symmetry is x equals 0. I'm going to make my eyes here. Over what interval is the function increasing? So I say, okay, it's going down there and then up there. So it's increasing when x is greater than or less than. So it's greater than 0, and then the other one's always the opposite. So it's decreasing when the values are less than 0. So when it's -1, -2, -3, all the way on to negative infinity, it's going to decrease. It's going to increase when all the values are bigger than 0. So 1, 2, 3, 4, 5, 6, 7, 8 goes on and on forever. So that's nothing new. That's everything that we've talked about so far. Now we're going to start something a little new, not hard though. So it says using your calculator, graph the functions y equals x squared, y equals 2x squared, and y equals 4x squared, and explain what happens. So we're going to start with y equals x squared. So at this point, everyone should be taking out their calculator, adding a graph, and we're going to type in x squared. So if I'm going too fast, feel free to stop the video and put this in your calculator and then start the video again. So here's the function y equals x squared. That's our parent function. And now let's see what happens when we put in y equals 2x squared and y equals 4x squared. So let's see. To get a new graph, you hit tab, and we're going to type in 2x squared. Okay, so there's our new graph, the red one. Let's see what happens with the 4x squared. We're going to hit tab again, type in 4x squared. So again, I'll give you a second to catch up. If you need to catch up with me, pause the video and put these functions into your calculator. So the question says, explain what happens to y equals x squared as the number in front of the x squared is greater than 1. So what happened? We started with our blue, then we go to our red, then we go to our black. The function is actually getting skinnier, right? It's not as fat. The blue one's fatter than the red one, and that's fatter than the black one. So explain what happens. We want to say the function becomes, and we're not going to use skinny and fat just because those aren't really math terms. We're going to use the word narrower, or wider? So the function becomes narrower, which means skinnier. Think about, you talk about like caves that are narrow, it's really tight, it's a tight squeeze, it's tight to get through that cave. So narrower means to get skinnier. You can make skinny. So now it says use your calculator, graph the functions, x squared, 1/3 x squared, and 1/9 x squared. We're going to see what happens. So I'm going to go to my new document. Do you want to save? No. Let's add a graph. So we're always going to start with our parent functions. Everything's based off the parent function. So x squared, enter. There's the beautiful x squared parent function. And now we're going to see how all the other graphs, the ones that they list, are compared to this one. So the first one I want to do is 1/3 x squared. So hit tab. That gives you another graph line. We're going to type in 1/3 x squared. And you get the red graph. So I'm sure you guys can guess what's going to happen, but let's put the other one in as well. Hit tab. Now we're going to put in 1/9 x squared. Enter. So as you can see, our graphs are getting fatter, right? We start with the blue. He was pretty skinny. Then he gets a little fatter when he becomes the red. Then he gets much fatter when he becomes the black function. So what happens in this case? We want to write the function becomes wider. We're not going to use fatter. That's just not correct in math. So the function becomes wider. Right? So you start the blue, goes to the red, goes to the black. It's getting wider and wider every time. So not too difficult. Again, this whole thing, you just want to put the graphs in your calculator, see what happens. Do they get skinnier? Do they get wider? What happens? So again, if I'm going too fast, feel free to pause the video and catch up with me and rewind if you need to. All right, we have 2 more problems here. So Ben graphed the function y equals x squared, and Alex graphed the function y equals 2/3 x squared. Compare Ben's graph to Alex's graph. So how are we going to do this? Whenever you have to compare graphs, you're going to go right to your calculator. So we're going to take our calculator out, go to a new document, don't save, add a graph, and we're going to add in Ben's function first. So we have Ben's, he's graphing the parent function, x squared. Great. Now we're going to put in Alex's. So hit tab. And Alex had 2/3 x squared. So 2/3 x squared. Enter. So now the question says, compare Ben's graph to Alex's graph. So Alex is red, Ben is blue. What is Ben's graph compared to Alex's graph? So I hope you have an answer in your head. Ben's graph is actually skinnier or narrower, same word, than Alex's graph. Alex's is a little bit fatter than Ben's graph there. So we want to say here, Ben's graph is narrower. Remember, that means skinny but the Regents doesn't use the word skinny. They use the word narrower. So Ben's graph is narrower than Alex's graph. And this is hard only because of the reading, but we'll make sure that you guys get this read if you get your test read. Ben's graph is narrower than Alex's graph, which makes sense. Look at Ben's graph. His is the blue, Alex is the red. So Ben's is narrower compared to Alex's. Give everyone a second to catch up here. Okay. So Tyler graphed two of his favorite functions. F of x equals x squared and g of x equals negative 5x squared. How does g of x compare to f of x? Well, let's see. Let's put our two functions in. So go home, add a new doc. Do you want to save? No, never. Add a graph. So we'll put in x squared first. X squared. There's our parent function. Now we're going to put in negative 5x squared. So hit tab, type negative 5x squared, enter. So we want to know, how does the red graph compare to the blue graph? There's two changes in this case. We've only talked about narrower or wider, but there's one thing that's different here as well. So first off, how does the red graph compare to the blue graph? Well, the red graph is narrower or skinnier than the blue graph. So that's the first thing you want to say. G of x, which in our case is the red graph, is narrower than f of x. But also, something else happened. As you can see, the red graph opens upside down. The blue graph opens upwards. So we want to say g of x opens downward, and f of x, which is the blue one, opens upward. Perfect. And the reason that happens is because there's a negative in front of the 5 there. So anytime there's a negative in the front, it's going to flip your graph upside down and make it a sad face. So when there's a negative in the front there, your graph's always going to open downward because it's a sad parabola. Negative, sad, upset. It's just a positive in front there. It's a positive parabola. Happy, positive, it's opening up. So that, I believe, I don't think there's another example. Nope. Okay. So that, I believe, is going to be the last problem on your notes. At this point, we will see where everybody is in terms of the stations. But if you have a little extra time, you can start your homework. That will be due on Monday. So I'll pause it here, let you guys get this copy down. And if you need to go back to anything, please do. And that is it. So make sure you keep these because these are your notes.